We want our learners to do more than mimic adults or older peers counting. We want them to have a sense of quantity and to be able to use counting as a tool for quantifying a set. To reach this point, children must put together a tremendous amount of knowledge and skill. They need to know the number word list so well that they do not have to use much cognitive load to state the number words in order. It also helps if they can say the number word list with a sense of rhythm to support them in applying it in one-to-one correspondence with objects. They need to be able to switch from the focus on individual objects being counted to thinking of the whole set and recognizing that the last number word is referring to the whole set. This aha is called the cardinal principle or cardinality. We can expect the vast majority of kindergarten children to have cardinality for very small numbers, but they will still be working on cardinality for larger numbers and into the teens. Cardinality is of prime importance in the Common Core and even features in the title of the domain, which is our focus in this PD module, counting and cardinality. Here we see cardinality specifically mentioned in Standard 4, and it is also expanded into several subpoints, including one-to-one correspondence, the special role of the last number stated when counting, and the recognition that each number in the sequence is one greater than the previous number. All of these ideas feature in this presentation, although the last idea, which we call nested numbers, is developed more fully in a different presentation. Counting really is the foundation of the number strand in mathematics. The purpose of counting is to determine how much or how many. This was a mathematical focus even in primitive man, with some artifacts still surviving, showing systems that they developed to figure out how many items in a set. Cardinality is essential to understanding the quantifying nature of counting, which in turn helps with Standard 5, count to find out how many. Frankly, counting and cardinality is also the foundation to all subsequent number strands, such as operations in algebraic thinking and number and base 10. Cardinality begins by abstracting that a quantity, such as 3, can be applied to many disparate groups, such as 3 days, 3 shirts, 3 sides on a triangle, and 3 wise men. We say that the numbers we use are abstractions of a quantity. The abstract nature is what allows numbers to be so useful to us. They can be applied to any set that shares that quantity. In order to come to this awareness of threeness, for example, a child needs to see that a collection of items must be able to be matched in a one-to-one correspondence to the number word list. One item to the first number word, the second item to the second number word, and so on. In the process, children will also need to see the importance of not skipping or double tagging during the correspondence process. When children begin kindergarten, they've begun this awareness already and probably already have this idea for small numbers. It is not uncommon, however, for them to skip or double tag, and seeing this is not necessarily a cause for alarm. We will be addressing counting errors later in this PD module with suggestions available at that time. We tend to think of counting as such an easy process, but there is some unbelievably difficult cognition going on there. To count a set meaningfully, the student must have prerequisite knowledge that we have already discussed, such as a solidly fluent number word list and one-to-one correspondence. In addition, the learner must be able to focus on the individual items in a set as he counts, and then shift gears as he comes to the last counting word and recognize that this number refers to the entire set. Although it might be tempting to tell a child that the last word means the whole amount, it is important to recognize that just merely telling the students this idea does not really establish it in their own minds with any kind of real understanding. This is an aha that the learner must construct for himself or herself. Most children have already achieved this understanding for small numbers prior to kindergarten, but you should give them a lot of opportunities to count and record the things you observe as you see children count. This will allow you to determine their areas of struggle. What we find is that some mathematical concepts do not develop in an entirely linear fashion. In the case of cardinality, it is such a big idea that we see students grappling with a set of related concepts that tend to develop in a somewhat symbiotic way. Although there is much to be learned about the development of beginning number concepts, there is some evidence to indicate that the development of cardinality is fostered by two related concepts of subitizing and nested numbers. The Common Core writing team has also written a series of companion documents called progressions. These progressions illustrate how the standards are related to other standards, both at the same grade level, and then how they connect to the standards across grade levels. In the counting and cardinality progression, there is specific mention of subitizing. The progression is even titled From Subitizing to Single-Digit Arithmetic Fluency. The authors see subitizing as foundational to arithmetic, and yet it is quite possible that you may not have even heard of it before. For that reason, we will be giving it some focused attention in an upcoming presentation. For now, we will call subitizing the capacity to perceive small quantities at a glance without counting. For example, it is not uncommon for a kindergarten child to recognize a quantity as 3 without counting 1 to 1, 1, 2, 3, just to see it and say, that's 3. That is particularly true when items are arranged in a familiar pattern, such as a dice pattern. Nested numbers are a recognition of how numbers are related to the numbers near them in the number word list. One more than the previous number and one less than the next one. So, how does subitizing prepare students for cardinality? Well, a key connection in cardinality is the awareness that a particular number word matches a particular quantity. Since young children, sometimes as young as 2, can begin to see the quantity of 3 items at a glance and label it as 3 without actually counting, this lays the foundation for the earliest concept of cardinality, to be able to see a group as a whole and figure out the number word that would go for the whole group. Recognizing and being able to label 3 items as 3, however, is not necessarily an indicator of cardinality. Nevertheless, when you work with particular finger patterns and simple arrangement items arranged in patterns, that can be really useful to fostering subitizing, and in turn, fostering subitizing can foster cardinality. Here we see references to the idea of subitizing in 2 other documents which influenced the Common Core authors. Mathematics in Early Childhood, a document that many of the authors have actually referenced in the progressions, for example, and in some of the videos they have about the Common Core, they've stated that that was one of their primary influences, and also the curricular focal points for kindergarten that was established by NCTM. If you are unfamiliar with subitizing, or if you aren't sure how to foster this capacity, this is an area well worth pursuing in your professional development, and we have one presentation that specifically addresses this as well. As I stated previously, when incoming kindergarten children come to you, already illustrating the cardinal principle for small quantities of 1 to 4 items, for example, you cannot actually assume that they've just got it. To attain full understanding of cardinality, they must generalize quantities to many diverse sets, including sets that cannot be seen. Being able to count things like days, for example, or time. They must also be able to extend their knowledge of cardinality for small numbers to increasingly larger quantities. So learning how to generalize quantity across many disparate types of sets and also learning how to extend it to larger quantities is a major focus for kindergarten. Students should count a lot. However much you imagine I mean when I say a lot, it is probably still not sufficient. It may help, however, to know that you do not personally need to listen to all of their counting, and it certainly shouldn't all be assessed. Assess their counting periodically so that you can identify progress and consider whether any particular supports might be helpful. But don't limit the students' counting experiences to only those isolated occasions when you can actually listen and assess. They need much more experience than that. So you don't need to constantly assess the students. You don't always have to be physically present when it's happening, as in situations where students might be at a counting center. But you should definitely seek some opportunities to engage with learners and invite them into dialogues about counting, including how they're keeping track, what they do when the numbers are very large, how they know what number comes next, etc. Although the terms of subitizing and cardinality are not vocabulary that you use with children, the underlying ideas are ones that you want children to grapple with. Dialogues can draw learners' attention to these foundational concepts. So, for example, you want to draw students into dialogues that talk about what does this last word that we just said mean? What does it represent? Does it just represent the last item I pointed to, or does it represent the whole group? What makes you think so? Those are useful dialogues to have with the entire group of students. The progressions document that I actually referenced here is such a useful document, a real gold mine of background material on the Common Core. So I've included the link where you can access that, and also the reference material for mathematics learning in early childhood, which was a